This is the homework for 319, 320, 321, 322, and 324. Problem 319. Determine which transformation was used on each pair of polygons below. So the first one, you can see here is the line of reflection, and it gives us that butterfly pattern or closing a book on top of another page, and here's the spine. So this one is a reflection. Each point is equidistant from the line of reflection. For E, you can see that there's a line of reflection. And here's the left side of the triangle, the right angle, and now it's on the right-hand side. And they're equidistant from the line of reflection. For part A, what is the slope of our line? So you could graph it, but I chose to use the slope formula, the difference of the y's over the difference of the x's. So here's point 1, x1 and y1, and x2 and y2. So it's the difference of the y's, 4 minus 1, and 2 minus 1. So again, the slope formula is the difference of the y's over difference of the x's. I could have done 1 minus 4 and then over 1 minus 2, but that would have given me negative values, so I just chose to go 4 minus 1. And now we have 3 divided by 1, which equals 3. So the slope of her line is 3. B, what is the y-intercept of her line? So if we were to graph it, the y-intercept would be where the line intersects the y-axis. But since I didn't graph it, I need to find the b value. This is the y-intercept, or the starting value. So the values I have the m, the slope, which is 3, and I also have a value for y and x. And I can use this x and y value, or I can use this x and y value. So I chose to use 1 and 1. I just felt that those were simpler values to use. And so instead of x, I place in the value of 1. And for y, the value of 1. I could have used x as 2 and y as 4, but I used 1 and 1. Now I simplify and solve for b. 3 times 1 is 3. And now the inverse property of addition and subtraction, so I subtract 3 from both sides, 0 pair. And 1 minus 3, I have more negatives than positives, so I know it's going to be a negative value. Signs are opposite, so subtract. 3 minus 1 is 2, so it's negative 2. So the slope, the b value, is negative 2. Or the y-intercept, since the y-intercept, the b value is at negative 2, the y-intercept, the coordinates is 0 on the x, negative 2 on the y. And then the last part C, is what is the equation of our line? Well, remember the equation for a line in slope-intercept form, y equals mx plus b. We know the slope, which was 3, and now the b, the y-intercept, is negative 2. So for this first one, we have a right angle, and that's indicated by this right angle here, which means it's 90 degrees. So we know that this angle, the pink angle, plus the purple angle, the measure of these two angles have a sum of 90 degrees. Since they have a sum of 90 degrees, these are complementary angles. Complementary angles are two angles when their measures have a sum or add up to 90 degrees. So since these two add up to 90 degrees, we can set them equal to 90 degrees. We have 6x plus 4x plus 10 equals 90. Now we can simplify by combining like terms. 6x plus 4x equals 10x. And now we're solving for x, so inverse property of addition is subtraction. So we subtract 10 from both sides, created a 0 pair. 90 minus 10 equals 80. And now we're solving for x, so this is multiplication. Inverse property of multiplication is division. We divide by 10 because this creates a giant 1. 10 divided by 10 is 1. And 80 divided by 10 is 8. So x equals 8. Problem 321b, we need to solve for x. And here we have what's called a straight angle. A straight angle is 180 degrees. And the sum of these two angles, since these equal 180 degrees, they're called supplementary angles. And supplementary angles are two angles when their measures add to 180 degrees. So we have this obtuse angle plus this acute angle add up to 180 degrees. So we have 5x plus 13 and 3x plus 7 equals 180 degrees. Combine like terms, so we have 5x and 3x, which is 8x. 13 plus 8 is 20. Solving for x, so inverse property of addition. Subtraction, so we're subtracting 20 from both sides. 0 pair. 180 minus 20 equals 160. 8 multiplied by x, it's multiplication. Inverse property of multiplication is division. So now we're dividing by 8 because it creates the giant 1. 8 divided by 8 is 1. 1 multiplied by x is x. And then 160 divided by 8 is 20. So x equals 20. For problem 322, we need to determine the domain and range for each of the graphs. For 322a, all the x values or the domain, you can see to the right, heading towards the positive x's infinitely, and also this graph is going to the left or to the negative x values infinitely. So the domain are all real numbers. The range, the y values, so now here's the y-axis. We have on the y-axis positive 1, and we go across, so it goes along positive 1, but it does not go, it's not greater than positive 1. So the y values are y equals, or y is less than or equal to 1. So any value less than or equal to 1. Nothing greater than 1. 322b, the domain or x values, if we look on the x-axis here, the graph starts here. So there aren't any x values. There's not an arrow that's going to the left towards the negative x values. It starts here. So my x values are going to have to be greater than or equal to this value, which is -1, -2, -3. So x is greater than or equal to -3. The y values, you can see that it's going up on the y-axis from here, but it's not going below it. So the y values have to be greater than or equal to -1, -2. So here's -2. So y, or the range, is greater than or equal to -2. It's the range. So on the x-axis, you can see these arrows are, it's infinitely going towards the negative values. And on the x-axis, this graph is infinitely going towards the positive values. So the domain are all real numbers. But the range, the y values, if you look at the y-axis, there are no values that are going to be greater than 0. Because here's on the y-axis, here's the origin, here y is 0. So y has to be, so the range is y is all values less than or equal to 0. No values are greater than 0. For D, if we look at the x-axis, On the x-axis, this arrow is going infinitely towards the negative x values, and this part of the graph is going infinitely towards the positive x values. So the domain, or all x value, the x values, are all real numbers. The range, this time, the graph is going up from this point on the y-axis. And the y-axis here is 0, here's -1. So the graph touches -1, but all the values are greater than or equal to it. So the range is y equals greater than, or y is greater than or equal to -1. There are no values less than -1. 324, we need to rewrite the expression in equivalent, simpler forms so that they do not contain negative exponents. So we don't want to have negative exponents. So what we're going to do is I'm going to go ahead and factor this out. So we have 4 multiplied by z to the -3rd. So 4 multiplied by z to the -3rd, and 20 multiplied by z to the -1st. Well, now we can simplify 4 divided by 20, simplifies to 1/5, because 4 divided by 4 is 1, 20 divided by 4 is 5. And now, if you remember, dividing exponents with the same base, you subtract them. So I have -3 minus a -1. -3 minus a -1. And if we distribute this negative, the opposite of a -1 is a +1. So now we have 1/5 multiplied by z to the -3rd plus 1. Simplify, -3 plus 1 is -2. We still have a negative exponent. So now we're going to go ahead and bring that down to the denominator. And z to the -2nd, bring it down to the denominator, it becomes a positive. And we're taking the reciprocal of it. And so now we have 1/5z to the 2nd. For b, we're going to go ahead and try to combine like terms. And before we do that, I'm going to use commutative property of multiplication. So to combine like terms, and so I'm going to put them together. So I have the y's together, and here I have 2 to the 3rd multiplied by 3 to the 2nd. These are not like terms, but these are, because they have the same base. So I can combine these. And when you combine integers with the same base, when you're multiplying, you add them together. So I have 8 plus a -10, and then I simplified 2 to the 3rd, which equals 8. 3 squared is 9. And we have 8 minus 10 is -2. And you can't, you don't want to have a negative exponent. So this goes down to the denominator and becomes positive, and we have 72 divided by y squared. Problem 324c. We need to distribute this exponent, and we have to distribute this -3 to both terms. And there's 2 terms here. And first, I'm going to put a placeholder here of a 1 as an exponent, because anything to the first power is itself, so I'm not changing the value of it. And now I'm going to distribute. When you have a power raised to a power, you're multiplying. So I have 1 multiplied by -3, and 3 multiplied by -3. 1 multiplied by -3 is -3. 3 multiplied by -3 is -9. And now we have to simplify it further by getting rid of the negative exponents. So we bring them down to the denominator. And now we have 1/6 to the 3rd multiplied by g to the 9th. And I'm going to go ahead and simplify 6 to the 3rd, which equals 216 g to the 9th.